Hello there and welcome to A2 Maths on Specimen Paper 1, and here we're looking at question 7, an integration question. Figure 4 shows a sketch of part of a curve with equation y equals 2e to the 2x minus xe to the 2x where x is real. The finite region R shown shaded in figure 4 is bounded by the curve, the x-axis and the y-axis. Use calculus to show the area of R can be written as pe to the 4 plus q, where p and q are rational constants to be found. Okay, first things first, I need to know what this value here is going to be. I know that the integral is going to be between 0 and something, but I don't know what that something is going to be. So the first thing I'll do then is set my equation equal to 0. So it's going to be 0 equals 2e to the 2x minus xe to the 2x. Now with exponentials, they're pretty good because you can divide by them. Not many algebraic things you can divide by, but we know that e to the 2x is always greater than 0, so we can always divide by it. So therefore 2 is equal to x. So I now know that my integration is going to be in between 2 to 0. So therefore I'm now going to start integrating 2 to 0 of 2e to the 2x minus xe to the 2x. Now, one of these expressions is going to be much more easier to integrate than the other. So what I'll start to do then is I'll start to split them up. The integral from 2 to 0 of 2e to the 2x dx minus integral from 2 to 0 of xe to the 2x dx. Okay, so the first one is the easy one. It's just a scale factor multiplier at the front. So with e to the x, it integrates to itself, but when there's a 2 there, we divide by the 2 to the front, so it's going to integrate to e to the 2x, and then have a boundary between 2 and 0. Now for the next part, we need to use integration by parts. So what we're going to do then is we're going to set, we have u and we have dv by dx. And then with one part of the integration, one part of the expression, we're going to differentiate it. So I'm going to suggest we take the x part and we differentiate that part, and we integrate the e to the 2x part. So v is going to equal 1/2 e to the 2x, and then du by dx is going to equal 1. And just a reminder of what the integration by parts formula is, it's the integral of u dv by dx, this is in the formula booklet so you can always look it up if you forget, is equal to uv minus the integral of v du by dx. You can see there that it's uv, and then it's the swapped around the other way version of where it is at the start. So u gets differentiated to du by dx, and dv by dx gets integrated back to v. It undoes its differentiation, and when you undo differentiation, you integrate instead. So what I'm now going to need to do is I'm now needing to subtract u times v, so that's going to be x, let's in fact do a square bracket, x times 1/2, I'll put half at the front, e to the 2x, and that's going to be integrated between 2 and 0, and then it's going to be taking away minus, so there's going to be a plus here of the integral from 2 to 0 of v times du by dx, that's just going to be 1/2 e to the 2x dx. Okay, good, so carrying on to the next page. We get this expression here. So let's now let's do the final integration bit at the end before we start substituting in. It's nice to substitute it all in one go, in my opinion. So that's the first bit now done. And then the last bit, the integral of this bit is going to be 1/4 e to the 2x. So we divide by 2 again, but we've already got a half there, so it's now 1/4 from 2 to 0. Now what I'm going to do first, I'm going to be a bit cheeky, is I'm going to substitute 2 into all of these expressions first and create one big bracket, and then I'm going to subtract 0 being substituted into all of these expressions here afterwards. So it's going to be 2 substituted in, that's going to be e to the 4 minus 2 times a half is just 1, so that basically cancels out, and then it's going to be minus e to the 4. And then it's going to be plus 1/4 e to the 4. And now it's going to be take away 0 being substituted in across the board. So it's going to be 1. Substituting in 0 here, that's going to give me just 0. And then it's going to be plus 1/4 here, because substituting in 0 into an exponential just gives you 1. So those two will cancel each other out. So it's now going to be 1/4 e to the 4 minus 5/4. So there we are, the value for P is equal to 1/4 and the value for Q is equal to minus 5/4. So there we are, it was integration by parts that was important for this question here on the first page. If you were a bit shaky on the integration by parts bit, then go back to the integration by parts chapter in your textbook, have some practice of that type of integration. Otherwise, hopefully this will have all made sense. Maybe this part with the limits was a little bit confusing. When you've got an integral with limits, let's say from alpha to beta, then you evaluate the u times v in between alpha and beta as well, so the integration by parts formula turns into something like this. Alright then, so that's 5 marks there for question 7, not too bad really. Let's now move on to question 8.